Okay, I wanted to work on some of the terms that we learned in class today. So this is right out of the section we were working on today, lines and planes, okay? So this is example number 2 from task 2 in your packet. So let me just make sure I'm on page 10 of your packet. So we're going to do example 2 and example 4. And I want you guys to try example 3 on your own. So answer the following questions about the figure. Name a line in the figure. So if we look at the figure and the definition of a line is a set of infinite points, and a line is 2 points that continue on in infinite directions. So if we look at this particular image, I can see, and bear with me, I'm going to use 2 different colors. I can see 2 very distinct lines that have been drawn in. The first is this line I'm trying to draw over in pink, and then the second is a line that I'm going to draw over in green. These are the 2 distinct lines that have been drawn into your picture. So when we're asked to determine which lines might be in the figure, there are actually a few lines that we can name. So remember, we need points to name a line. And so I'm going to start with the pink line. So if we look at the pink line, we just need 2 points on that line to label it. So we could label it line SP, and then above it we'd put the symbol of a line. Or we could also label it line ST, or we could label it PT, because all 3 of those points lie on the pink line that I've drawn. Another option, let's look at our green line for our second line that we drew. There are only 2 distinct points that are shown on the green line. So let me get rid of the green so it's crystal clear. Okay, so just quickly look at this picture. I want you to be clear from the picture, since I drew over it. When there's a dotted line, that implies that this dotted part is under the plane. So this line starts above the plane and cuts right through the plane. So there are only 2 distinct points that are defined on the green line. So we'd have to label it QP, or I suppose we can use that little lowercase n, right? Or we could label it NQ or something like that. Not sure why it's lowercase and everything else is uppercase. Okay? So the question for B would be, are the lines PQ and ST skew lines? Okay, so now that we're doing the other 2 lines, I'm going to go ahead and take a look at the picture without any pink or green. PQ, that's this line, and ST, that's this line. We are asking, are they skew lines? So go back to your definition of skew lines. Skew lines are lines that are not in the same plane. Okay, well, that's true because line ST is in plane, let's say VPR, but this line QP does not lie in plane VPR. It cuts through plane VPR. So the first part is accurate. These lines are not in the same plane. But skew lines are not in the same plane and they don't intersect. So we're going to have an issue here because our 2 lines intersect right here at point P. So skew lines are not in the same plane and don't intersect. Well, we want to write down that P and Q, our lines, PQ and ST, intersect at point P. So they are not skew lines. It's not possible for lines to be skew if they intersect at a point, okay? They do satisfy the first part of the definition, that they don't lie in the same plane. But that second part is that they don't intersect. They're supposed to be almost, they're like parallel lines, but they don't lie in the same plane. Okay, finally we're asked in part C to name two distinct line segments in the figure. Okay, so let me get my eraser out. It says two distinct line segments. So let's just erase everything that we've drawn on our image so far. If we want two line segments, then that would be distinct, just means unique, right? So not that we don't want to name the same segment. So let's think about naming, pick two segments here. We could name segment QP, that's one segment. And we could also name this segment right here on the side of this plane, M and R, because those are two distinct points. So we have segment QP, and when you name a segment, you just put a segment over it, no arrows. And then the other line segment we're supposed to be naming, let's say, would be lowercase m, uppercase r. Again, not sure why there's some lowercase letters and some uppercase letters with that same notation above. There are many other segments we can name here in this picture. So if you want to try to name a few and check with me after the fact, please do. But what I'm going to do is look at example number 4 next. So let's go. On example number 4, we have a new picture. Everything's labeled, our lines here in this case are labeled with lowercase letters A and F, and then all the points are the uppercase letters. So every point where each of these segments intersect to make this box is considered to be one of these uppercase letters, okay? Remember that dotted lines are behind the planes that we're looking at. So right now we're like almost looking through a 3-dimensional box. So first we want to name two lines that are parallel. So this is same plane, don't intersect. Okay, so in the same exact plane, but do not intersect. So let's do these in pink. So two parallel lines. We might consider, I'm going to look sort of like I'm at the front of the box. This line right here in pink, FB, and line GC, those are parallel. They would never intersect. And because they're both on the front of the box, they are on the same plane. So in pink, just to match the picture, I'm going to say two lines that are parallel would be FB and GC. Those are two parallel lines. There are many other pairs in this picture. So if you'd like to name a pair of parallel lines and then send it to me in a message or come to office hours and guess with me, more power to you. I love that idea. All right, moving on. We're going to go to like a purple color, so each thing is in a different color. It says, are FG and AB skew lines? Okay, so this is FG, and this is AB. Our question is, are they skew lines? And we did this in our last problem. So remember, skew lines are different planes. So that's true based on our picture. One's on the top of the box and the other is on one of the sides that's not directly connected to that top. So I do believe that we can consider these two separate planes, right? One's sort of the bottom and one's the front face. So yes, they are on different planes. And then we also need to ensure that they don't intersect. And in this case, that is true. We have one line coming off the top of the box, and the other line is on the bottom of the box. So these lines will never intersect. Yes, they are skew lines. Okay? So we have two more questions to go, and then we're finished up. So let's do green for the next question. It says, name two lines that are perpendicular. Okay? So perpendicular are, again, same plane, but this time they're at a 90-degree angle when they intersect. So because this is a box, I'm going to take a look at the top, right? And we'll say that, sorry, I did something weird with my iPad. My bad, guys. EH and, I'm trying to make a straight line here. I didn't mean to go to slide 3, guys. EH and HG are perpendicular because this is a box. Every angle is a 90-degree angle. So we can say that EH and HG are perpendicular. And finally, name two lines that are coplanar. Okay, so let's do this in kind of like a yellow color so we can see it. We want something that's coplanar, and these are two lines. So we know what lines are. Coplanar, if you look at your notes, says they lie in the same plane. So in order to answer this question, I'm going to erase some of the colors here and take a look at some stuff that lies in the same plane. Okay? So let's take a look at the top of the box. So EH and EF are coplanar. Okay, and right again on the top of the box, I can go back over here and say EH is coplanar with FG.